And so for magnesium oxide, we want to this one was important. And let's try another one. Okay, let's try for aluminum sulfide. So aluminum would be Al3+ like this, and then sulfide would be sulfur. It's in group 6. If you check your periodic table, let me actually go back here. So sulfur, it's in group 6. So there are several ways by which a sulfur creates its compounds. We say that it has several valencies, but normally it's in group 6, so it's 2-. Okay, so and then the other one, just like what we saw here, the other one is calcium. The other one is aluminum, and it is 3+, as in it's in group 3. Okay, it's in group 3 of elements. So what you do here is I'll actually use the space here. So aluminum and sulfur. So let me actually just separate here. So aluminum is 3 valence, sulfur is 2 valence. Okay, so the smallest ratio is 3:1 again. Okay, and then you just write aluminum sulfide like this. Okay, it's 3:2, just like this, the smallest ratio. So from the smallest ratio, sulfur is 2, so we repurpose it to the aluminum part. And then aluminum has 3. We are simply exchanging. This one takes this one, this one takes this one. Okay, so that's why the formula is like this. Okay, remember this one has to be the smallest ratio, and I'll actually illustrate now why that is necessary, and that is so. So here you have magnesium, so you'd have Mg2+. If you check in your periodic table, have it handy. Okay, your periodic table, you realize that it's in group 2 magnesium, and oxygen is in group 6. So group 6, we say the group 6 elements, they form 2-. Okay, normally. So here you'd have magnesium and oxygen. So here you'd have 2 and 2. Okay, so the smallest ratio is actually 1:1. Okay, you can divide each number here by 2 and then get 1:1. That's why magnesium oxide is like this. Okay, it's not like this, because if you don't take the smallest ratio, you're going to write it like this, which is incorrect. This is not how you'd you'd be expected to write it. Okay, so it actually be MgO. So if you go through many questions like this, you actually develop a keen eye for these things, and then you tend to realize, oh, magnesium, it's 2. Yeah, this 2, it has to be repurposed here. This oxygen is 2. This 2 is repurposed here. But then, oh, 2, they have a common factor here. It's 2, so the smallest ratio is 1:1. So that's why we have to put 1 and 1 here. Another way to do it is to just work out as many formulas as possible. Then you just know that sodium chloride is a certain way, such that if you write anything that's kind of riddled with an error, that's kind of riddled with errors, then you just know. So for this one, it's nickel 3 chloride. Okay, so this is important. Nickel here, we are given 3 here just because it's called a transition element. Okay, we are not really sure of the valencies, because for transition elements, the valencies can be different. Okay, they have multiple valencies. So nickel, if you are given nickel and then you're given 3 here, it simply means that the nickel that you're dealing with, it's 3+. Okay, nickel, it's a metal. That's one way to look at it. So it's a cation here. And then for chlorine is in group 7. Now you probably know it's simply Cl- like this. Okay, so what you do is, again, let me repurpose this part here. So nickel and chlorine. So nickel, it's 3, chlorine, it's 1. Okay, so the smallest ratio is 3:1. Okay, so nickel, then chlorine, then nickel, chlorine, 1. We repurpose it on the nickel, so we are switching the valencies. And then this one, 3. So that's why it's nickel chloride like this. Okay, nickel 3 chloride is this formula here. So I hope that you understood what we're talking about here, what you're supposed to commit to mind, It's simply the writing the cations and the anions, writing these ions here. It's very important. And then you're also supposed to be mindful. You're looking for the smallest ratio. Sometimes you have species that have like common factors. For example, in their valences, for example, magnesium 2 plus and oxygen 2 minus here. You're supposed to deal with the smallest ratio. The smallest ratio will give you the ratio which you can repurpose to get your valences. Okay. So what I realized is before we actually close, what I realized is that ZIMSEC sometimes they give you so what I realize is that ZIMSEC sometimes they give you hypothetical situations. Okay, so they can tell you, let's say the ions there, X 2 plus, and then let's say Y 3 minus here, like this. So what would be the compound that would be formed? Still, it's the same thing. You just go your elements here. Okay, so your elements are X and Y. Okay, then you write your valencies. Your valencies are 2 and 3, like this. Okay, so smallest ratio. Your smallest ratio is 2 is to 3. Okay, so therefore the compound would be X. Then you write your Y. Then this one you repurpose it here. You are exchanging. Okay, and then this one you repurpose it here. So you'd actually get X like this. This would be your element. Okay, and then the other question that's a bit tricky as well is that they can tell you the group numbers, and then they tell you can you get the valence, the formula. So for example, you can be told that one element is in group, let's say 6. Okay, one element is in group, let's say 3. Okay, so one element is in group 6, and so let's call this element P. Let's call this element X. Okay, so that we can use symbols that don't conflict with the existing symbols in the periodic table. So you're supposed to know an element in group 6. It's what? It's 2 minus. Okay, go back again to your periodic table. You'll be able to see that it only needs 2 electrons in order to achieve octet. Then an element in group 3, it's 3 plus. Okay, and once you have figured this out now, you can go back again and say my elements are X and Y. The valences are for X it's 2. The valence for Y it's 3. Okay, and then the smallest ratio is 2 is to 3 again. Okay, so the element would be, then you repurpose the valences. This one takes 3. We're switching. This one goes to this. This one goes to this. This one would be 2, like this. Okay, and then if you've done this, then you have killed it. And sometimes, let's say they tell you that this is group 3, this is group 2. So let's say this is group 2. So this one would be 2 minus. Remember 6, you only need 2 to get your 8. Then here, this is 2 plus. Okay, so you have X and you have Y. The valencies there, 2 and 2. The smallest ratio, so smallest ratio is 1 is to 1. That's why the element should be just XY, not X2, Y2. Okay, so that's it for this. We're going to do, after some time, we're going to do for other compounds as well that include like cations, which comprise various elements in there. For example, the carbonate ions. Okay, so the carbonate ion, the nitrate ion, we are also going to do how to deal with those formulas. So thanks so much for watching. This is Yuba. I'll catch you in the next video. Cheers.